Okay, so today in class we talked about the properties of parallelograms. There was a yellow note sheet on page 71 in your notebooks, and I basically just typed in those same things we discussed in class so you could just kind of look at those. And what I'm going to do now is I'm going to do some examples that involve algebra, but they relate to these properties. So what we have to look at is what is given to us in the problem and which of these properties we can use to find the value of the variables. Okay, so I'm going to do 3 examples. All right, so the first one is actually example number 2 in your textbook on page 295, example number 2. So let me draw in a parallelogram. And it's labeled at Q, R, S, P, P, Q, R, S. Okay. And then they give us some information, and the information is given here, 3x minus 15. That's the length of QR. And the length of PS is 2x plus 3. So, based upon what's given, they are giving me the length of 2 sides, specifically 2 opposite sides, and we know from one of these properties that opposite sides are congruent. Therefore, I'm going to set those congruent to each other. And the directions say, in this example, to find the value of x and then also to tell us the length of QR and PS. Okay, so let's go ahead and let's actually solve this. We want to get the variables on the same side. So when I solve for x, I'm going to get that x is 18. Okay, so that's one part of what I'm supposed to do. Now I'm supposed to then find out the real length of QR and PS, which we really only have to do one time because they're the opposite sides and opposite sides are congruent. So if we find out one, the other is the same. So we're just a matter of taking this value of x and either plugging it in here or here to find out what the value is. So just so I have less to multiply with, I'm going to do this one here. So PS will be the one I do. And it says that it is 2 times x. Well, if x is 18, then I'm doing 2 times 18 plus 3. So that's going to be the same thing as 36 plus 3, which is 39. And that will also be the value of QR because they are opposite and opposite sides are congruent. So we're just using one of these properties based upon the drawing that's given and solving an algebra problem. Okay? All right, let's do another example. And again, this is all based upon what's given in the problem. Let's do the check understanding for that one, number 2. For example, number 2 on the bottom of page 295 in your textbook. So let me draw that parallelogram. Okay, and it's labeled E, F, G, H. And again, some information is given to us. And the information given is that angle G is 3y plus 37, and that's degrees, so that gives you a clue that we're dealing with angles. And then that angle E is 6y plus 4, and again it says the degrees. So we're dealing with angles. Well, the only ones that deal with angles are number 3 and number 4. Are E and G consecutive angles or opposite angles? Well, they're opposite. They're across from each other. So opposite angles are congruent. So again, I'm going to set them congruent. And then I'm asked in the problem after I find the value of y, or of the variable, then I am asked to find the measure of each angle. Angle E, angle F, angle G, and angle H. So once I find the value of x, I can find the others. So again, these are equal to each other, so that's what we're going to do. We're going to set them equal to each other. So collect the variables on the same side. And when I divide by 3, I get that y equals 11. Now that's just what the variable stands for. In order for me to be able to actually tell what these angles represent, I'm going to have to take this 11 and either plug it in here or here, because remember, E and G are equal to each other. They're congruent. So it really doesn't matter. So I'm going to actually plug it into this one here. 6 times y, which is represented by 11. That's going to give me 66 plus 4, so that means that angle E is a 70-degree angle. So I'll write that here. And if E is a 70-degree angle, so is G. So I'm going to write that for G as well, because they're opposite and opposite angles are congruent. So what we have left to fill in are F and H. Well, F and H are opposite of each other, but they are consecutive angles with E and G. And as we know from this, consecutive angles are supplementary, or they add up to 180. So if angle E is 70, then angle F is going to have to be 110, because 110 plus 70 equals 180. And that also makes H 110, because opposite angles are congruent. So there you have the angle measurement. So see, this example used angles as one of the properties. So you have to look at what's given, again, in order to tell, and then use the properties in order to tell what you have to solve. Okay, let's do one more. Okay. So this last one is just another example that is there in the notes. Actually, I think it's in one of the practice problems. All right, so let me draw a large parallelogram. And this time we're going to draw in diagonals. And then here's the information that's given to us in the diagonals. 6y plus 1 is that side. 4y plus 9 is that side. 2x minus 5 is that side, or the side of the diagonal. And this side of the diagonal is x plus 7. So the only one of these properties that deals with diagonals is number 5. Diagonals bisect each other, which you should remember. If they bisect each other, that means that they meet somewhere. And when they bisect, it means that each piece or each side of the line is equal to the other side. So that means that this side and this side are equal to each other, and this side of that diagonal and this side are equal to each other. So that helps us set up the equation that we're going to need to have. And that is actually going to have to be two equations, because I have an x and a y. So the first one is these two are equal to each other. So I'll do that one over here. And again, I'm just simply solving for x. And we get that x equals 12. They're not asking us to actually write the diagonals. They're just asking us to solve, okay, and find the variables. So we're not actually finding lengths of anything. And then I have to do the same thing over here. So 6y plus 1 equals 4y plus 9. And again, getting the variables on the same side. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . And when I solve for y, I'm going to get 4. So x is 12 and y is 4. Again, I'm just using one of the properties and applying it to an algebra problem. Now there are also an example 3 and an example 4 in your notes. Example 3 actually involves an algebra 1 concept, which is solving a system of equations, and that's just really taking it an extra step that it doesn't need to go. So we're not actually going to do anything on like number 3. You won't have any test on it. There won't be any homework on that because it involves 2 different variables and you can't solve them using one of them. Okay? And then on page 297 in your notes, we're also not going to be really doing much or discussing much with that theorem 6-4. So you don't have to worry about example number 4 either. So it's just really example 2 is the last of that lesson. Okay, now when on the next video, I'm going to be discussing how to look at a parallelogram, or what we think is a parallelogram, and confirm whether it is or isn't. And again, it's still going to be using these properties, which is going to be the converses.